Students are not here at the room, right? I don't know. But anyhow, now we'll discuss and we'll write a review, right, for these questions. So where are the other people? Did you check? Say to go to Bata. Correct, I mean, like, wait, two people, and then entire that, right? Anyhow, I hope at least everyone I said now whether they are covering or not in the class. It is must to cover, right? Like there is like must sessions. Okay. I will share the screen. After that, we'll write. You guys also have to speak. Hari, better if you can unmute and speak. Nathan chat take Hari. If you can speak, then we need that. Yeah. So whatever I'm speaking, everything clear, right? Sounds are okay. Sounds are fine, Nebuta. Right. Oh, hariද? Right. The unmute and speak අපි conversation එකක් විදියට මේක will do right? Because don't Like when we are only speaking Katawa, it's annoying to do. So you guys also can interact with me. Now, these are some short questions to answer. So we'll see how to do these parts. First one, in which of the following responses does the activity discovers matches correctly with the name of the relevant scientist? Okay, who found the EM ratio? Yes?
Thompson.
Yes, very good. JJ Thompson. Everyone try to speak, not only one person. Right? Thomson, he found the EM ratio, right? And he only discovered electron, JJ Thomson. So radioactivity? Yes,
Becquerel.
radioactivity. Becquerel. So Thomson and Becquerel mean then directly no need to check the other ones. Automatically we have the answer as the third one. Because theory of filling of electron and atom is Aufbau. He only told that. What is Aufbau's principle? How Aufbau, what did he do? He only told the pattern. What will fill first? Okay. Then distribution of electrons in the valence shell of atoms, molecule or ions. Okay, that is said by the Lewis structure. Okay, that is Gilbert Lewis. And the electron can behave as a wave. Okay, KLQA, de Broglie. Can you remember the de Broglie's formula? Yes, people. Can you remember de Broglie's formula? Speak, speak. Everyone speak. Guys, me. Don't waste the time. Can you remember? Can't. Can. Chat together, reply. Tagga. One note. Chat together. Go reply. Common chat together. If you can't remember, now at least remember de Broglie's formula is right. Lambda is equal to de Broglie's wavelength. Right. Remember, lambda is equal to, okay, remember this formula. Lambda is equal to H over, right, H over mv. This is the de Broglie's formula, right? H over mv. mv, yeah. H over mv. What's happening? I don't know. It's difficult writing this. PowerPoint can write make it to come out. Lambda equals H over mv. Okay. H means Planck's constant. M means mass. V means velocity. Okay. H over mv. Okay. Very hard to write. Anyhow, lambda is equal to H over mv. That's the formula. Sometimes you might know lambda equal. Okay. Yeah, we have the part to everything. Right? Don't worry. We will discuss one by one. Then you will get these parts. Okay. Then this is lambda equal H O M B only. We have to write it. Next one. Two atom contains one unpaired electron in each of their valence shell. The quantum number is relevant to these unpaired electrons are as follows. Here they have given. Okay, so what is the first one? You can have from the number 4. Okay, two atoms contain one unpaired electron in of their valence shell. Only one unpaired electron in their valence shell. Okay, again others are paired electrons. So they have given this quantum, the quantum number sets relevant to these unpaired electrons. Unpaired electrons mean the last electron, whatever the last electron. Normally unpaired electron will be the last electron. Nothing here last electron we can't say. Sometimes unpaired electron can be a mid electron. As follows. So here they have given, right? Now you can see this part. Here they have given, this is 4. Then this is 4 mean I have to write 4 here. Right? This is 4. 0 mean what? What orbital is this? 0 mean? What orbital is this? Right? What orbital is this? 0 mean? What is the
S.
orbital? S
S.
orbital. Okay, then this should be 4s. Okay, 4s. Okay. Again, 0 mean what? What is the other 0? This orbital has only one subshell on a subshell they have given. AK only plus half mean this is actually 4s1. So who is having a 4s1 electronic configuration out of these people? Only
A.
potassium. Only potassium having the 4s1 uh, electronic configuration. Then when you come for this one, next electronic configuration, you can see this is 3. Okay, this is 3. 1 mean what? 1 mean that is P. So this is 3p. 3p is 0 mean the middle orbital. Actually, P has 3 orbitals like this. P has 3 orbitals like this. Okay. 1, 2, 3, we can write. So I don't know, there's some issue with this app. Very hard to write. I'm feeling like difficult to write in this. Okay, so we got 3 subshells like this. Okay, then each subshell. Okay, 0 mean the middle subshell, this one. This middle one only 0. Then that is only 0. Then when you take the phosphorus, phosphorus is in the 15th group. 15th group mean it is S2P5. Okay, S2P5. Then okay, the quantum number sets relevant to those unpaired electrons. What issue you got? Right. This later. So there is some problem here, but later I'll take another one. I hope I can write here. Okay. Now see this part. I hope you can see this. Right? In this part, now I have to speak this question. Now in this question, they have told 2 atoms contains 1 unpaired electron in each of their valence shell. The quantum number sets relevant to these unpaired electrons are as follows. And the 2 elements respectively are here they have asked. Right? You have to find what are the 2 elements here. Okay. So they have given these quantum numbers for the unpaired electron. Okay, unpaired electron. Now out of this, what are these unpaired electron? We'll see. One is 4s1. Okay, I'll put this question to this area. Okay. These are very good questions. Actually, it's a very good question. See this. That's why this session is very important. Now, Buddha, this is 4s1. First of all, you have to see who are having 4s1 configuration. Okay, first of all, you have to see who are having 4s1 configuration. Now, in this, who are having 4s1 configuration? Right. Tell me the people who are having 4s1 configuration out of the first people. Potassium is having a, speak will you people. Potassium having a 4s1 configuration. Okay. Potassium is okay. We are see who are having 4s1 configuration. Huh? We are see who are having 4s1 configuration. Okay. 4s1 configuration. So potassium is having a 4s1 configuration. That is okay. Now the next one is phosphorus. Do they have a 4s1 configuration? No. Right? Potassium. Potassium. Right? When you come to copper, does copper has a 4s1 configuration? Copper?
Yes.
Copper also having a 4s1 configuration. Answer is yes. Why? Because copper, you know, copper is the 29th element. Therefore, copper will feel like this, right? Copper is 29th element. Therefore, its last orbital will be 4s1 and 3d10. Okay. So, this is the configuration of copper. Okay. Copper is 29th. Even chromium. Chromium is 24. If you see that, you can see, so chromium also is having a 4s1, 3d, 5. Right, 4s1, 3d, 5 configuration. Even these people also, copper and chromium also having, right, 4s1 configuration. Iron is not having a 4s1 configuration. Sodium is not having a 4s1 configuration. Therefore, fourth and fifth answers I can reject. Okay, fourth and fifth answer I can reject. Right? You guys try to select the answer. Right. Now to the next one.
Okay, there are some interesting facts. Now the other one is they have told relevant to these unpaired electrons are as follows. But they have told these people's having 3p. 3p mean like this. You got 3 subshells like this in P. Then this one is in the middle one. So it should feel like this. 1, 2, 3. Then 4. Because this 3p, okay, 3p, and this should be in the 0, okay, and it should be minus half, right? Okay. Then what should be the best answer? Yes. If you take chlorine and you have actually a problem with the chlorine or phosphorus, the key. Now, which one should be the answer? Chlorine or the phosphorus? What should be this? If it chlorine is 17. 17 now, it is in P5. P is 5. Okay. This phosphorus now, it is S2 P3. Okay, no? S2 P3. Okay. Now, which one is the answer? Yes. It's supposed to be phosphorus or not chlorine. You're going for the what? Second answer. Again, copper and chlorine, that one. Others, what do you think? Everyone tell your answers. What the ඔයගොල්ලෝ හිතන්න? Yes. You can tell your answers, guys. Only ideas you can tell. What might be the answer or not? Yeah. You can tell your ideas. මේ question එකේ පොඩි issue එකක් තියෙනවා වගේ. Right. Okay. Yes. Second, first. Now they have told 2 atoms contain 1 unpaired electron in each of their valence shell. Right? Only 1 unpaired electron. That is fine. Then the quantum number sets relevant to these unpaired electrons are as follows. They have given a 4s1 configuration. Other one is they have given 3p. එතන තමයි issue එක තියෙන්නේ. Because of this question only we can go for a proper answer. Because in phosphorus there are 3 unpaired electrons, so I can go for this. In chromium also there are like all these are unpaired electrons. No? The chromium also I can't go. Then definitely second one should be the answer. But can you see there is a problem in the question? Okay, can you see there is a problem in the question? But they have told if you want to select chlorine, chlorine means this one also get filled because it is P5, because it is P5. Then S2P5 means, but where is the unpaired electron now? In which orbital the unpaired electron is there? In 0 or +1? Speak quickly. No, this is 0.
+1.
Yes, this is -1, this is +1. So, why, if they have given the valence electron killer, that is okay. The quantum number sets relevant to these unpaired electrons are as follows. They have given the quantum number sets for these unpaired electrons killer. Can you see that? So if you take this one as the unpaired electron, actually this one supposed to be +1. Okay, this one supposed to be +1. Okay, then we have to change the question. This one as 1, 3, 1, 1, -2 kilo, but okay, it can be plus or minus, it doesn't matter. Is it clear, Putta? May question like actually nice question. When I go okay, whatever necessary things, write that. Huh? Okay. Does it go over the next one? The make first of all, right? Then we'll go for the next one, third one. Actually, it's a nice one. So you guys also should speak. We'll go to the next one. The next one is this. Which of the following statement is false? Hi. You only have to write a description here. Properties of cathode rays do not change according to the gas filled in the emission tube or the substance used as the cathode. That is true or false? That is true. Okay, because cathode rays mean what is that? That's an electron. Okay, that's an electron. Right? Therefore, that is true. Very good. Aim speak, Karan, right? Guys, speak. Okay. You put your answers in the chat box. Next one, positive rays produce shadows of object kept in their path. Okay. That also true. Because positive rays, it possess what properties? It is a matter. It has, okay, again, positive rays it's not a electromagnetic wave. Okay, it has particle-like nature. Because why they produce shadows? Because they have a particle-like nature and they travel in a straight line. Okay, that's why they produce a shadow. Okay, that is also true. Cathode rays move with the velocity of light. What do you tell about that? Do they travel with the velocity of light? That is wrong. Okay, they don't travel with the velocity of light. They travel just closer to light, not with the velocity of light. Okay. Number 4. Particles present in, that's the false answer. We selected the answer as the third one. What particles present in nuclei are called as nucleons. Yes. Nucleons mean protons and neutrons together are called as nucleons. Correct, no? Okay. Mass of an electron is 1 over 1837 times as the mass of a H plus ion. H plus ion mean it's a proton. Okay, H plus ion mean it is a proton. H plus ion mean that is a proton. Okay, remember H plus ion mean that is a proton. So mass of an electron is 1 over 1837 times than a proton. Therefore, that is true. So the false one is third one. That's part is clear. Now we'll go to another one. All necessary things take, right? Now we'll come to the fourth question. Good. Now I have to take one by one to this side because I can write something. Now let us see the fourth one. Fourth. Let's see the fourth one. False statement regarding the gold leaf experiment of Rutherford. The majority of alpha rays move without being deflected. What is Rutherford's experiment? Using Rutherford's experiment, they found the nucleus. Okay. Who were the other two people assisted Rutherford? Their name? The other two people who assisted Rutherford? Yes, Geiger and Marsden. Very good. Okay. Geiger and Marsden. If you can't remember, at least at those points. One is Geiger, one is Marsden. Geiger and Marsden, they only assisted Rutherford. So you can include that. And the other part is majority of alpha rays move without being deflected. That is true because most of the areas were empty. That's why it traveled like that. Next one, electrons move in constant orbitals. Is it true? That is false. Electron does not move in constant orbitals. They absorb energy, they release energy, and they can change their orbitals. Okay? Right. That is false. Third, that is the answer. Second one is the answer. It proved that an atom contains a large empty space. True, because most of the alpha particles went without deflected. A positive charge accumulate in a single place of an atom. Yes, that's why some rays, whatever went directly to the atom, whatever directly went to the nucleus, they reflected with large deflective angle. When an alpha particle comes near the nucleus, they move by getting subject to the large deflected. Yeah, that's also true. Then the false one is second one. Right. Now these things are fine. Next question. Right. So the next one they have asked, number 5. Which of the following is not true regarding the atomic emission spectrum of hydrogen? Okay. Now they're asking about this atomic spectrum of hydrogen. Okay, I'll take this and explain. Okay. Now, Buddha, can you remember about hydrogen spectrum? In the hydrogen spectrum, whatever the lines come to the first energy level, what we call for that? What do you call for that? First energy level? Can you speak?
Lyman.
Lyman. Second?
Balmer.
Oh, tell me the names. Balmer. Then? Lyman, Balmer. After that?
Partial.
Partial.
Bracket. Fun.
Bracket and fun. Very good. Lyman, Balmer, partial, bracket, fun. So these are the 4 series. These are the 5 series. Okay, what we had. Okay, so now they are talking about the spectrum. First of all, they are talking about which is coming from 4th level to 2nd level. Right. Okay. First of all, we'll draw some lines. Okay, the first energy level. Okay. Then the first energy level. Then the second energy level. Now we'll keep it here. Okay, second. Third energy level. We'll keep it here. 4th energy level. Okay. And 5th. When you're going upward, the energy difference should reduce between the energy levels. Energy difference should reduce. Right. Now, first of all, they are talking about the lines which is coming from the second. Okay. Right. So I will draw. Now they are telling if someone come from this level to this level, this is 3rd to 2nd. Okay. This is 3rd level to 2nd. And if another line come from this level to this one. Okay, these are only which whatever coming for the 2nd level. Right. Then there is another one. It is coming to a third level. And this one, okay, like this. From the fourth level. Right. So when these, you can see everything are coming to the second energy level. Okay, everything coming to the second energy level. So what we call for first one, actually. You get the shortest one. It means this line only having the shortest energy. And therefore we call that as, okay, this line, whatever the line here, this we call H, right? This is only H alpha. The other one is H beta. Third one is H gamma. Fourth one is H delta. Okay, so these are the four energies like alpha, beta, gamma, delta. Okay, so then see the statement. Okay, see the statement. The line H beta represents the emission from N4 to N2. Is it correct? That is correct or wrong? Tell me, correct or wrong? N4 to N2. Now this is N1. This is N1. This is N2. This is N3. This is N4. Now see H beta. Where is H beta? From fourth to second. Then that is true. Okay, that is true. And see the B part. The ionization energy of hydrogen is the energy difference between, okay, that's in alpha anyway, that is in infinity to N1. That is correct or wrong? What do you think about the B statement? True or false? B? B is, yes, very good. B is true, right? B is true. Why? Because what do you mean by ionization energy? Okay, ionization energy means the energy required to remove an electron, right, until it goes, right, the maximum distance. Okay, until you have to remove that from your maximum distance. Only maximum distance you come to remove whatever the energy needed. And that is only first ionization energy. First ionization means you will remove the electron and that electron will go over somewhere. Then it is something like where is hydrogen's first electron? It is in the first energy, first level. So from that level, you have to remove it until the infinity. Then what is the first ionization energy mean? That is actually the difference between the infinity and the first level. Right? I hope you can understand. Right. Didn't understand the B statement. Now did you understand? After explanation? Is it clear? Is it clear or okay? What is first ionization energy? First ionization energy means you are removing an electron in the gaseous state. You remove this electron in the gaseous state. What do you mean by removing electron? Removing electron means you will remove this electron and you will send it to infinity. Again, you will send it to maximum away from that. Okay, maximum away. Maximum away can almost it is like infinity. So what is this energy? This energy means first ionization energy means the energy required to remove this electron and send it to where? To infinity. Then this energy difference only what? This energy difference only we are taking as first ionization energy, right? To send here to here the energy required. There is the ionization energy of hydrogen is the energy difference between N, this is infinity, yeah? Infinity to N1. That is, now, did you understand that? Clear? Everyone? Okay, so that is very important. Good. Right. Nice. Now, Buddha, so that is the answer, so don't forget that. Okay, that is only first ionization energy. Now, next C part, each line of hydrogen spectrum represents the energy of an energy level. That is true or false? Each line of hydrogen spectrum represents the energy of an energy level. That is true. That statement is false. That statement is false. Why? What is the wrong statement, you know? What is the issue now? What is the problem here? Right? What is the problem? Yeah. What is the problem? Yeah, the problem is energy difference. Okay, not spectral represents the energy of an energy level. I mean, energy anyway. This is the wrong here. This is the wrong one. This statement is wrong. Not energy. It represents the energy difference of an energy difference. Okay, each line of height in the spectrum represents the energy difference between energy levels. Okay, so if you take this line shows the energy difference between third energy and second energy level. Okay, so each line shows the energy difference, not the energy. And remember, clear? Right. Okay. No, it doesn't. It not wavelength. Okay, it represents energy difference. Right? Clear? Understood, right? Next one, energy difference between N2 to it's not A1, it's supposed to be N1. Energy difference between N2 to N1. See the energy difference between N2 to N1? This is N2, this is N1. This is the energy difference. So this is only the energy difference. We'll take delta E1 kilo will take energy difference. Delta E1. Okay, energy difference. ඊට පස්සේ N2 to N1 energy level is smaller than the energy difference between N3 to N2. N3 to N2 kilowatt. N3 to N2 is this. So that statement also what falls, right? So N3 to N2 is smaller than N2 to N1. Therefore, what should you tell? It's about this one also. Wrong. Then correct statements are A and B. But they have asked what is not true regarding. Not true C and D. Okay. So actually a nice question. Even after selecting the question, there is a twist. But they have asked not true here. Okay, not the true one. They asked not true. Okay. Okay. Now understood. Write the necessary explanation now. Right? Mainly write the necessary explanation. That is very important. Okay. Right. We're going to mark these things. Okay, now we'll go to the next one. So the next question is about a calculation. Next question is about a calculation. Sixth one. That's related to some calculation here. Right. Velocity of particles with a mass of 3.313 into 10 to the minus 28 gram is 1 into 10 to the minus -1 de Broglie wavelength of the particle. So what is the de Broglie wavelength? What is the formula? I told in the beginning.
Lambda equals h over mv.
Very good. Lambda is equal to h over mv. So here if I put the lambda is equal to h over mv. Now this is the formula. Okay, what is h? H value I have given 6.6. How much? 626 into 10 to the power minus 34. 10 to the power minus 34. Okay. Joule seconds. J is joule seconds. Over m is how much? 3.313. M is 3.313. 3.313. 3.313. Right into the minus 28. Into the minus 20. Then I can also they are also for velocity. Velocity they are going to do. If you simplify, how much will you get for this? 4 minus 28 minus 34 become minus 6. Then minus 6 and 4 comes up minus 10. So this becomes 10 to the power minus 10. Now this will come in meters. So if you want to convert to nanometers, multiply by 10 to the power minus 9. Okay, nanometer. Okay, like millimeter mean 10 to the power 3, micrometer mean 10 to the power 6, nanometer mean 10 to the power 9. You have to multiply this by 10 to the power 9 after everything. Then finally 3.313 and 6.626 we can simplify, that is 2. Then answer is 2 into 10 to the power, okay, 10 to the power minus 1. Any issue, any problem? M we have put in kilograms. Okay, M is in grams. So I have to convert that to kilogram. So if I convert this to kilogram, again I have to multiply by 10 to the power minus 3. So 10 to the minus 3 comes up, mean answer will be 2 into 10 to the power 2. 2 into 10 to the power 2 should be the nanometer. This should be nanometer. 2 into 10 to the power 2 nanometer. Okay, then answer step. Clear? Okay, now actually like these are easy questions now. So when you are doing this only, it will come to a practice. Alright, okay. Now up to 6 done fine. Number 18. Number 8. Sorry, number 7. Number 7 is about the relative atomic mass. Now this is related to relative atomic mass. Sorry. Now tell me how to find this. How to find the relative atomic mass of chlorine 35.5. The mass percentage of them respectively they have given. Now give me some idea how to find. You guys know, right, how to find this. Okay. What should you do? They have given the relative atomic mass. So you have to multiply the abundance. Like you have to multiply with the abundance. So what is the percentage they are in? Now what is the amount of chlorine 35 here? We don't know that. So chlorine 35, I'm going to write like this. Okay. I'm going to write chlorine 35 going to be 35 chlorine will be X percentage here I'm taking. X 100 plus 37 chlorine will be the balance of X. No? So it become 100 minus X. 100 minus x over 100. And this should be equal to how much? Their relative atomic mass. Okay, what is the relative atomic mass here? The relative atomic mass is 35.5. 35.5. 35.5. Right. So this is the relative atomic mass for this. Now what should we do? Okay. We now if you simplify this, now we got to simplify. Then if you simplify this to the, how much will you get for x? That is only important. How much will you get for x? So this will be 35x here. This will be minus x now. Then minus 37x. 35x minus 37x. Then this side will be 3700. So you get here, if you simplify the top part, right, you get 3700. 3700. Okay. 3700 minus 2x. Send the division 100 to other side. So 35.5 into 100 mean 3550. So send the 2x to this side, send the 3550 to that side. So find x become. When 3550 come to this side, you get 150. Then send the 2 to this side, division 2. So x will be equal to 75. So this x value will come as 75. This x will come as 75. So if x is 75%, right? If x is 75%, then you will get the value, right? If x comes as 75% mean, then what is x here? 35 chlorine. So 35 chlorine is 75% mean. What should be, there is no answer no, in this. Second answer you have to change as 75 and 25. It should be that way. So that one should be the answer. Second answer. Second answer you have to change as 75 and 25. Change it as 75 and 25. This one should be 75. This one should be 25. Eh? This one should be 25. Okay, so 75 and 25. This should be the answer. Everyone clear? How to get this? With the relative atomic mass, you have to see how their relative, whatever the mass there. Okay, we have to multiply by its percentage. Fine. Fine. Okay. Now next. Okay. So Tagala write the necessary things. But the Tagala things are getting recalled with this, no? Nothing. Is it good? But what do you think about this session? Is it useful? Komal. People tell you ideas. Akkari daan kocharak useful, the like very useful, the like how many like things are getting recalled or it is useful. Akkari apita the akkari kiyano. Tell something what is useful for us. Right. Okay. Next one, number 8. The number of unpaired electrons present in Cr3 plus, Ni2 plus, and Cu2 plus ions respectively. Right. Now you have to see this part. What is the number of unpaired electrons present in Cr3 plus, then Ni2 plus and Cu2 plus. So what is Cr3 plus? The chromium, you know. Chromium's electronic configuration, that is S1D5 or S1 3D5. Okay. That is only this one. Then for S1 3D5 mean if 3 electrons go from this way, First of all, 3 should go. Okay. Then if 3 goes from this, 3D5 OS1 again, 3 goes mean finally you get 3D3 you will get. So this is for chromium. Cr3 plus. When you come for nickel 2 plus, what is nickel? What is the nickel's number, Putta? Nickel is 28, right?
28.
28. In 28 now, what is the electronic configuration? 4s2 3d8, right? 3d8. 4s2 and 3d8. Then 4s2 3d8 mean when two things go on mean this 4s2's 2 electrons only they will say. Again, when these people are removing electron, they will remove from this one first. Then 8 will be there. Then they have asked number of unpaired electrons. In 3d8, do you have any unpaired electrons? Do you have any unpaired electron?
No.
No. So that will be no any unpaired electrons. This unpaired electrons will be 0.
0.
This unpaired electron will be 3. Yes, Cr3 plus unpaired electron will be 3. Nickel 2 plus unpaired electron will be 0. Copper 2 plus. Copper 2 plus means 3d10. Copper is 29. 3d10, 4 is 1. In copper 2 plus what will happen? This 1 electron from S will go, 1 electron from D will go. It will become 3d9. 3d9, now how many unpaired electrons are there? Only?
1.
Only 1. So what should be the correct answer then? 3. Okay. 3d8 now how many unpaired electrons will be there? 0, sorry. Not 0, no? 2. 2 unpaired electrons will be there. 2 unpaired electrons should be there. By 3d8 number in D block there are 5 like this. 1, 2, 3, 4, 5. So 8 means first of all, first 5 will fill like this. 1, 2, 3, 4, 5. After that, 6, 7, and 8. Then these two are unpaired. Then this will be 2. So 3 to 1 is the answer. Answer is second. And are these things clear?
Yes, sir.
Nice. Now, next one. They have asked ascending order of the covalent radius of lithium, sodium, beryllium, and magnesium. Now in this part, Putta, so tell me how the radius changes when you're going from left to right. What happened to the radius, Putta? Increase or decrease?
Decrease.
Yes, very good. Left to right, radius will decrease. Top to bottom?
Increase.
Very good. Radius will increase. Right? Radius will increase. Now, when you take lithium and beryllium, lithium is here. Lithium and beryllium, lithium is here, beryllium is here. Then when you take lithium and beryllium, definitely lithium is greater than beryllium. When you take sodium and magnesium, sodium is below lithium. Sodium is below lithium. Magnesium is next to lithium. Right? So next to sodium. This sodium, this is magnesium. So when you take lithium and beryllium, lithium is greatest. This lithium is big. When you take lithium and sodium, sodium is big. Right? When you take sodium and magnesium, still sodium is big. The sodium should come to the top place. Who should be in the smallest place? Then beryllium. Beryllium is the smallest, sodium is the largest, and Evage, which answer is there? Only the beryllium should be the smallest, sodium should be the largest. Which one is the answer, Buddha?
First one.
Answer. No, that's very good. Answer is first one. Answer is first one. Right. Good. Now next part.
Sir,
Hmm.
covalent radius and ionic radius both are same.
Covalent radius and ionic radius both are not same. Both are two things. Covalent radius is the radius in a covalent bond. Ionic radius is the radius in a ionic bond. Okay. Okay.
Okay.
Okay. Now next part. Number 10. Number 10 is related to chemical calculation question. Right? Number 10 is related to a chemical calculation part. Okay, now let's see that. Question number 10. The residue obtained after subjecting 10 grams of mixture containing sodium carbonate and calcium carbonate to thermal decomposition was 8.68 grams. Right? The sodium carbonate does not get subjected to thermal decomposition, while only calcium carbonate decomposes thermally to produce calcium oxide and carbon dioxide. But I remember, since you guys are grade 12, it means grade 12 first term. That's why they have given this information. Which information? That sodium carbonate won't decompose here. But if you come to A level, they will never give this statement. If you come to A level, they will never give this statement, because this is a statement only for grade 12, because you will learn this part in unit 6. Okay. But now you have to understand, now they have told already, so nothing new. Sodium carbonate, right? Sodium carbonate, they have told. Sodium carbonate, the sodium carbonate, that won't decompose. Sodium carbonate won't decompose, right? Only calcium carbonate decomposes. Only calcium carbonate decomposes thermally. So when you write calcium carbonate, okay, when you heat calcium carbonate, what will you get? You'll get calcium oxide and you get carbon dioxide. You get calcium oxide and carbon dioxide. So calcium carbonate will decompose into calcium oxide and carbon dioxide. Then Putta, okay, earlier there was a mixture of calcium carbonate and sodium carbonate both. Calcium carbonate also was there, sodium carbonate also was there. Okay, both only together, we got 10 grams. Now they have told the mass of the residue. Okay, only sodium, calcium carbonate to thermal decomposition was, okay, residue obtained. Residue mean what? What is now residue? Residue mean, now what you will have? You will have now this calcium oxide and this sodium carbonate, and these both together, this blue color both together, you will have 8.68 grams. Blue color is 8.68 grams. The red color is 10 grams. That is 10 grams. Now they have asked the percentage by mass of sodium carbonate in the original mixture. They have asked what is the mass of sodium carbonate. Right. Now we can do like this. No? If I take, we got X amount of calcium carbonate mole and Y amount of sodium carbonate molecule if I take, then the calcium oxide moles also will be how much? X, right? Calcium oxide also will be X. X no according to stoichiometry. Can you all understand that? Calcium carbonate is X mean calcium oxide also should be X. No? Then they have given the mass. They have given the mass. Yeah, they have given this mass. They have given mass is equal. Yeah, what can we do? Calcium carbonate, if you take the molar mass, calcium is 40, carbonate is 60. So it will be calcium carbonate's molar mass will be, so molar mass of calcium carbonate, and it will be 100. Molar mass of calcium carbonate will be 100, right? If you come to the sodium carbonate, okay, molar mass of sodium carbonate will be, right? Molar mass of sodium carbonate will be, sodium is 23, 46, so 106. Sodium carbonate molar mass is bigger than calcium carbonate. This is 106. So what can you write? You can write like this. Okay. X mean, X number of moles mean 100x. 100x plus 106y plus 106y. And that is equal to, okay, 106y. That is equal to 10 kilo. You can write an expression. Second expression. This is X mean calcium is 40, oxygen is 16, then 56. So I can write 56x plus 106y again is equal to 8.68. Now you are getting two simultaneous equations. Okay, you are getting two simultaneous equations. So using this, what can you do? You can minus first one minus second one. If you minus the first one by the second one, first one minus second one, what will you get here? Okay, first one minus second one, you will get here 100 minus 56, you get 44x. No? So you get here 44x is equal to 10 minus 8.68 mean you get 1.32. Okay, so now x will be equal to how much? 44 into 3, I guess, 132. Yes, then 0.03 you get. So x become 0.03. So if you find x as 0.03, Puta, x will be 0.03 moles, but we want y. So x is 0.03 moles mean you can use anything for this. You can use for the first one. If you use for the first one, 0.03. Okay, if you use instead of x, if you use 0.03 for this. Okay, so 100 into 0.03 is 3. Then 10 mean, okay, it become 10 minus 3. 10 minus 3 is 7. Then y equal 7 over 106. So y you get number of moles will be 7 over 106 moles. But we want the mass. No? Find the mass. What can I do? 106 into 7 over 106. Okay. So number of moles of Y is 7 over 106. Mass of sodium carbonate is 106. So what can I do? So finally I get this one as 7 grams. So sodium is 7 grams in this. So you want to see the percentage of sodium. So 7 over 10, you can multiply by 100. So 7 over 10 into 100 will be how much? Okay, 70% will be the answer. Right, 70% will be the answer. So answer is fourth one. Answer is fourth one. Right. Clear? Right, the next things. So how calcium oxide is a residue? No, but the calcium oxide is a solid. Okay. Can you see they have given calcium oxide solid key in this? Residue mean whatever remains, like whatever remains after burning this entire portion, some part will remain, and whatever remaining in that, because sodium carbonate didn't decompose. Sodium carbonate will remain as sodium carbonate. Then calcium oxide will remain as calcium oxide. Okay, clear? Then calcium carbonate will change to calcium oxide. Then some amount of carbon dioxide has released. So whatever the released carbon dioxide only, release carbon dioxide only, how much? 1 point, that grams. Okay, whatever the 1 point, 32 grams, under that is carbon dioxide. If not, you can do in this way too. Okay, you can think now 10 grams has reduced to 8.68. Again, what mass it has lost? 1.32 grams loss. So what is that 1.32 grams? Under that only carbon dioxide. And have a carbon dioxide, release carbon dioxide only 1.32 gram if you take. Okay, whatever the release carbon dioxide is 1.32 grams if you take Puta. Then finally you can find the number of moles of carbon dioxide. From that you can come for calcium carbonate, this one. And you can come for this. Okay, and are these things clear? All right. Now this part is okay. Right. So calculation now okay. Did you understand the calculation? Okay. Uta, did you understand this part, people?
Yes, sir.
Okay. Now, we'll discuss the questions without calculation. Okay, like whatever without calculation, we'll discuss now. There are some calculation question and Etika will discuss in the next session. Or without calculation, we will discuss now. What in everything calculation. Now, we'll see 16th one from 16th one. Those are not calculation. We can get those answers. Right. Now, okay. Now tell me which of the following reactions is a disproportionate reaction. So this is the first one, disproportionate. What do you mean by disproportionate reaction? Okay. What is a disproportionate reaction?
Reaction having both oxidation and reduction.
Very good. The same substance should undergo oxidation and reduction. Same substance mean, then definitely you should have two substances in the next side. But I think the first side, do you have two substances? No. The right side only there should be two substances. Can I same items, two things should be there. See, Br only one, hydrogen is only one place, oxygen is a Gomat shape. Sodium, no, this is, you can't get this one. Here also, you can't get this one. Okay, disproportionate reaction you can't get in this. Why? Because you don't have two substances in the right side. Then see the C thing. You have NaCl. Here there is a Cl. Here there is a Cl. Both the places there are Cl. Right? What is the oxidation state of the Cl in this? This Cl is zero oxidation state. This chlorine is -1. This chlorine is okay +5. Then you have 0 chlorine has gone to -1 chlorine and +5 chlorine. Therefore, C is what? Okay, C is a disproportionate reaction. C for D part also, this phosphorus is 0. In this phosphorus is -3. In this phosphorus, if you take here +3, -4, +1. Okay, so +1 of phosphorus and -3 phosphorus, then 0 has gone to -3 and +1. It means it's a disproportionate reaction. Okay, therefore, here C and D are disproportionate reaction to the. Therefore, answer is, if C and D are the correct answer, so what we have to select? Okay, C, D means answer is third one. Can I have proof? Third one, A, B, B, C, C. Clear? Right. Which of the following statement is true regarding alpha, beta, and gamma rays? Taggala will see that part. Gamma rays deflect towards the negative electrode. No, gamma won't deflect for any direction. Why? Gamma is an electromagnetic wave. Okay, gamma is an electromagnetic wave. B part, alpha rays are not deflected in a magnetic field. Okay, alpha rays are not deflected in a magnetic field. Wrong. Alpha rays will deflect in a magnetic field. Alpha and beta will deflect in magnetic field. Gamma won't deflect in electric or magnetic field. So the C part, EM ratio of beta rays are higher compared to that of alpha rays. Answer is true. Why? Beta is it's a electrons. Okay, so their mass is low. Alpha is helium nucleus. Therefore, their mass is high. Therefore, their EM ratio is low. Okay, so EM ratio of beta is high mean that is true, right? D statement, the deflection angle of beta rays within the magnetic field is larger than the alpha radiation. That is also true. Okay, why? EM ratio is more mean deflection angle is more. Okay, the more be EM ratio, the more deflection. Therefore, C and D are correct statements. Then answer for this one also. Third one, Kila, you can write. Are these things clear, Buddha?
Yes.
Everyone? Everyone? Taggala reply, yes, no. Right? Good. Now the next part. Okay. Which of the following responses given only in isoelectronic species? Okay. Which of the following responses given only isoelectronic species? Now, what are the response given in isoelectronic species? Who are the isoelectronic species in this? N3 minus. So nitrogen having 7 electrons. 3 minus mean when they take 3 minus meaning they will take 3 electrons. So they will have 10 electrons. O2 minus 10 electron. Argon 10 electron. Al3 plus aluminium having 13 electrons. 3 plus mean they have given 3 electrons. Then totally they also will have 10 electrons. Right? Therefore, A is the isoelectronic series. Argon P3 minus Cl minus, no, that is not isoelectronic series. P3 minus Cl minus S2 minus are same number of electrons. They all got 18. But argon, argon having 18 electrons. No? Okay, argon is having 18 electrons. Therefore, A is not isoelectronic series. B is an isoelectronic series. Okay. C part, neon having 10 electrons. F minus having 10 electrons, O2 minus having 10 electrons, N3 minus having 10 electrons. Therefore, C also isoelectronic series. Magnesium 2 plus having 10 electrons, Al3 minus, then they are having 16 electrons. Cl minus will have 18 electrons, N3 minus will have 18 electrons. Therefore, D also not isoelectronic series. Then here BC is the answer. Then answer is second one. We can. Anna, did you understand for the 18th one? 18th one clear?
Yes, sir.
Okay, nice. Now, Tagala will go to the right. Now, they have asked a ionic radius gradually decreases as you move towards right along a period. What will happen? When you move to right side, what will happen to ionic radius? Ionic or covalent, whatever radius, what will happen? It will decrease, right? It will decrease. Halogen group has the highest electronegativity from all the elements within a period. What can you tell? That is true. Okay. So halogen only having the highest electronegativity. Third one, shielding effect as well as effective nuclear charge increases as you move forward in the third period. shielding effect, will it increase? Will shielding effect increase when you move move in the same period? Will the shielding effect increase? Tell yes or no? No. Okay, shielding effect we are telling you it won't change. Okay, when you go when the number of shells increases, only actual shielding effect changes, right? If will effective nuclear charge increases, that is yes. Effective nuclear charge will increase when you move from left to right. Why? The number of protons will increase, therefore effective nuclear charge will increase. Therefore, C statement is not true. T, the first electron gain as well as first ionization of nitrogen are endothermic. Okay. First electron gain, that is endothermic or exothermic? Endothermic. Why? Who are having plus this one? Okay. Again, like now, first electron gain and first ionization of nitrogen are endothermic. That is true, Putha. Right? You know there are three type of people having first again electron gain is normally exothermic. Three people are having endothermic electron gain. Who are those three people? One is second group people. Another one nitrogen. Other one is 18th group people. Right? Save it in your head. Only these people having positive electron gain. Okay, second group people, nitrogen, and the 18th group people. Number 20, which of the following, then answer is fifth one, you have to go because A is correct, B is correct, D is correct. Now the 20th one, which of the following are true? They have asked. All elements contain more than one isotope. That is it true? Does all element contains more than one isotope? Tagala reply. Tagala reply. Right? Tagala message jack. Answer is no, right? Yeah. Answer is most of the elements. Most of the elements having more than one isotope. Okay. Right. Now, normally, who don't have isotopes? Right. Tell me the elements who don't have isotope. Who don't have isotope? Tell me a few elements if you know. Normally, when we can remember like fluorine. Fluorine is the most electronegative atom. So they don't have isotopes. Like fluorine, you can remember fluorine and sodium. Sodium fluoride. Sodium no isotopes. Fluorine, they don't have isotopes. And when you take gold, they don't have isotope, right? These are some elements, they don't have isotopes, right? Okay, though these are important, okay? Fine. Next. Isotopes of the same elements are nucleotides that are different from each other. Okay, what do you mean by that? Isotopes of the same element are, what is nucleotide? What is a nucleotide? Nucleotide is a, what is a nucleide? Nucleotide name, it's supposed to be a nucleide. What is a nucleide? An element having a mass number and atomic number is nucleide. Okay. So isotope of the same element are nucleide that are different from each other. That is true. Okay, that's a nucleide. Those are different. Okay. What is different? Even physical properties are different. Okay. Physical properties are different. Then all isotopes of the same element have equal abundance and stability. That is false. Okay. All isotopes of the same element have equal abundance. They have different abundance. Same element have different abundance. For example, when you take oxygen 16 is more abundant than oxygen 18. Okay, when you take chlorine 35 and chlorine 37, chlorine 35 is more abundant than chlorine 37. Okay, therefore, those are different. Yeah, that is also false. So, what are the true things? B and okay. B part I didn't, B statement I didn't read. No? Even though the atomic numbers of isotopes of the same element are the same, their mass numbers are different. That is true. Okay. B is correct, C is correct. Then answer is B, C. No? Answer is second one. Kutha, can you understand all these things? Is it clear? Okay, did you learn
Yes.
something? Okay, I just want like, which one was best session? Like last week's session or today's session? Last week chemical calculation practice or today's session, which one like more effective? Let them both were effective. The name of body comment, please put it in the chat box. Clear idea. Chat box. Okay, right. Give the comment on today's session as well as last week's session. You compare. Okay, please. Everyone. To complete the balance question, we will discuss those questions. Right.